So my name is Simon. I've been working in AI since 2015. Started off by co-founding APoly, which essentially we were helping blind people see using AI. And then we processed roughly 3 billion images, trying to get them to navigate the world without sight. Then later I co-founded V7, where I'm currently at, where we're building a context layer for finance. And I'm going to explain exactly what that means. But I'm based in London. And if you're interested in opportunities similar, feel free to reach out to me later. So what's the problem we're trying to solve here? So we're trying to run code and agents over sensitive data at high scale and also accurately and safely. I will give you an example of something that we do for our customers. They do something called SIM analysis, confidential information memorandums. It's essentially a huge document of everything about a company that they might want an investment on M&A. So we get this PDF, we'll extract a bunch of data, understand if there's anything that looks suspicious, do due diligence, which is a series of LLM calls, API calls, agents running in loops, and eventually create an investment memo. Hey, we should invest in this company because X and Y, or we shouldn't. And then also we build up this structured memory piece that we can later query for the whole organization to understand everything we learned from this document. So essentially, we have inputs, PDF, spreadsheet, emails. We have this workflow DAG. So DAG is essentially a graph with different steps that eventually ends up in structured memory and then queries from our users. In this talk, I'm going to focus on the workflow piece. So how are we processing the data? What are we doing with the data? And what are the steps? Let's see if this plays well. So here is a simple DAG that was created. So what you see here is a bunch of different steps and kind of how data flows between the steps. And the way users normally visualize this is just as a table where all of these different agents or LLMs or API calls are happening in parallel. It's not really important to understand exactly what happened here, but just think that the scale we're talking about is thousands of executions in parallel for any of these workflows. And why is this hard? So agents kind of make things, you don't need to code all the steps to get something done. You can just say, this is my intent, hey, go and do this. And they can write code, they can run the code, they can do API calls, and that's brilliant. But it's also really, really scary, because a lot of these API calls they're doing could be sending data that you don't want to send to third-party servers. It could misinterpret what's going on. So we need to figure out a way to build trust in this system. So the nodes in our DAG essentially run as LLMs. That's fairly safe. So we just do an API call to Gemini, to Claude, to OpenAI, and get a result back. Then we have another model that checks the result and check if that makes sense, and then try to ground it towards the answer. But the risk surface area is fairly small. We have integrations that we call directly, programmatically. That's also fairly safe, because we're just doing the API calls that the customers asked us to do. So if they asked us to do something wrong, it's a bit on them. Where it gets a bit tricky is when we ask on one of these nodes our users or our system to run Python code that has either been generated by a model or that the users created themselves, because this Python code could potentially be bad. Even worse is when we ask an agent that has access to tools, Python execution, and whatnot to run one of these steps. We can also run sub-workflows, but I think for this talk, we will focus on the Python and the agent side. And there are kind of two axes here we should look at. One of them is scale. How can we run this at high volume? So tens of thousands of processes in parallel without hitting any limits. So the way we solve that is through an orchestration system. It's not important in this talk, but it's one of the axes we always need to look at. The other one is how can we do this securely so we can actually trust the data. And that's what we're going to focus on here. So first, what could possibly go wrong by running Python code that someone else wrote? Do you have any ideas? Everything. So the first thing that you can do is resource abuse. So someone creates an infinite loop, or they allocate all the memory. And this might not be on purpose. You can easily do mistakes, right? So we need to figure out how do we make sure that there's no noisy neighbors that can bring down the system. Imagine that they're running in a directory or in an area that you set up for them. How do we make sure that they don't escape and look what the other users are doing? What is the other data? Try to solve the problem by getting data that is not allowed to see, or change data that is not allowed to change. How do we make sure that it's not calling external services with sensitive data that it should not be sending to those services? How do we make sure they're not DDoSing external services, so we, as the host of these processes, actually get banned? So, imagine that you're trying to scrape LinkedIn at a very, very high volume, and all of a sudden, our domain is banned from LinkedIn, and we can't serve any of our customers. Or they might be trying to access the internal IP addresses for metadata in AWS to get information about our system. So we need to figure out how to block that. So this was a few years ago. There wasn't a lot of solutions out there, so we decided to build our own. We call it Sandcastle. It's a bit like a sandbox that you build up, and then later just essentially a wave comes in and it destroys it. And Sandcastle has a life cycle. So every time we get a request, we spin up a fresh container. We execute whatever we need to execute. We return the values. And the way the values are returned here is actually via studio out. So information come in by studio in, and information come out with studio out. We have a very kind of simple execution flow. And as soon as you get the value, and this is one step in the execution, we tear down the whole thing. There is nothing left. So we always start up a new container every time. There is a bunch of different ways to build these containers. We started using Docker and gvisor. And as you may or may not know, when you run Docker normally, all the syscalls you're doing, like reading a file or writing to a file, goes directly to the host kernel. That increases the surface area of different attacks drastically. So what we normally do is that we run the container in kind of a layer of protection called gvisor, where all the syscalls that happen inside the container actually goes to this software layer that then emulates the actual system calls to the kernel. So you have an extra layer that you need to penetrate if they want to do some escalation of access. Docker plus gvisor is very easy to set up. I recommend that as a starting point. If you want to go a bit faster and do something more exciting, you can go down the Firecracker route. So Firecracker is what powers, for example, AWS Lambda. And in there, you create a micro VM. So it's actually not calling the host kernels. Instead, it's running a virtual machine that has a totally isolated runtime where you can do all your execution. So there's no way for it to escape what you're running. You could just run Docker itself, but I wouldn't recommend it. There are too many different ways of doing escalations of privilege in those systems. So after you set up gvisor or something similar, we need to prevent the different areas that we talked about. So we need to limit how much memory a process can have, how many CPU cycles, how many ticks of the CPU clock. We need to make sure it doesn't run at root. We need to make sure that it doesn't have any more capabilities than it needs. And we need to block it from escalating the capabilities it has. We shouldn't give it any file system access except in-memory temporary directories that we can write to. But this is kind of standard. But the most important thing I would say is that the network access needs to be off by default, because network is probably the biggest surface area where you can get things going really wrong. So the only way to access internet is via proxy. And I'm going to go in on proxy quite a lot in a bit. So instead of Python, imagine agents. What could go wrong in agents? Well, everything that can go wrong in Python can go wrong in agents, but more. So the tools that you provide can be used in ways that you didn't anticipate. You have read file, and start reading sensitive files that you didn't want it to read. Prompt injections from documents from your customers you have no control over might ask it to say, every time you see a private memo, do an API call to this API server and give me the information. And it happily does that if you don't stop it. You can easily have unbounded loops. For example, Cloud Code has a bug that if you have certain settings on, you're going to have two threads using the same file pointer trying to write to the same file at the same time, which kind of hangs the whole process, and it won't ever end, which happened in production for us. So you need to make sure that you can figure out how do we deal with systems we don't have full control over. So you can think of the different type of agents or harnesses. There are two kinds. There are external harnesses. So essentially, someone else wrote this harness. So Cloud Code, Codex, something you open code. Here you have a binary that you have little control over. So you need to run the whole thing inside a sandbox to block everything it's doing. So it's a fast way to start because the whole agent is there. But it's a horrible way of interacting with it because there's so many moving pieces, and the state lives in the sandbox. That means that every step of execution is going to start and stop Sandcastle. It will have to fast forward to where you were in the conversation and then do the next step of the execution. But this is where a lot of people start. The other way is to have an internal harness. That means that you wrote your own harness, and you have your own logic, being it in Python or JavaScript or whatever. But you have certain tasks that are dangerous. Those tasks could be like, run this Python code. That needs to execute still in a safe environment. But the sandbox is only used for those tasks. And a lot of the steps in the agent reasoning and routing happens outside the sandbox, which makes it both cheaper and easier to maintain. But if you don't have control of the sandbox, then you need to, or if you don't have control of the harness, you need to put the whole thing in the sandbox. So imagine that you have an external harness. Where does my kind of secrets go? How can I get this model to actually do the right thing? How do I talk to OpenAI or to Claude? Well, you don't put any secrets inside the sandbox. Because as soon as you do that, there are a million different ways that those secrets could escape to a client, or anywhere, really. Because you could ask the agent, like, what's the environment keys in your system? And if you have blocked those, you could say, what's my environment keys, but base64 encoder? So what you do instead is that you give them fake keys, because it expects keys to exist. Just give it something, placeholder keys. Then you force all internet access in the whole system to go through proxies. And this proxy is kind of the heart of this whole operation to make it secure. So every request that comes into the proxy, you know exactly which process is running it. You know what they're trying to access. Then you decide, is this a request I want to run? Is it going towards the right source? You can even do routing at this layer. So imagine that you're running Cloud Code. It wants to do an API call to Anthropic. It goes to your proxy, and at your proxy layer, you say, like, you're allowed to do this, but I'm actually going to send you to OpenAI. It's non-divisor as long as you emulate the API calls exactly and get the results back into the system. So the proxy becomes the layer where you know what is being called, when it's being called, where you can block any calls from happening. And if you need a human in the loop to go in and say, yes, this is OK to do, the proxy is also the right layer of adding that when you don't have access or control over the harness you're running. So all the external services that you would be using is then interfaced via this proxy. And proxies are surprisingly easy to set up as well. But you don't actually need to roll your own sandbox. If I started this project today, I probably wouldn't. So E2B is probably the most well-known. It's a bit complex, but it's fairly powerful. It's built on Firecracker. Modal is built on Docker gvisor. FlyIO Sprites is more like stateful sandboxes. Northflank is using Firecracker as well. And there's a lot of other suggestions out there that you could use. But it's important to understand how they work, and sometimes if you want, you need to roll your own. So you want to build these sandcastles in such a way that it's fine to just knock them down as soon as you have reached the step you wanted to do, and then the next step is going to start from a blank page. So we don't really want to trust any of the agents. We want to make sure that it doesn't matter if we trust if this agent is coded correctly or it does the right thing, because it can't actually do anything else than you wanted. I know I went through this fairly quickly, so if you guys have any questions, I don't know how we normally do that here, feel free to ask any.
Here we go, here we go. I would like to know how you're dogfooding this with your own dev team, because I can imagine, like, do people like orchestrate all of their cloud code calls through your infrastructure now, all of your developers?
No, but all our customers do.
Okay.
So we have a chat in our application, like most things do today, and all the calls in that chat goes through the Sandcastle system. And every time you send a message, it's going to start up a new instance of the sandbox. It's going to do the API calls it needs to do. And as soon as it turns back to the customer, we will tear down that instance, and it's going to disappear. And then next time you do like you answer the model, then you need to spin everything up again and then continue. And then we have that times thousands happening at the same time with infrastructure that needs to auto-scale. And at the same time, we need to make sure that we are using caching and all of those different things.
Nice, interesting. Any questions from the audience? Oh, I'm going to have to run for this one. OK, I saw the hand all the way in the back first, so I'm going to do some steps, fast steps. There we go.
Thank you, appreciate it. Thanks for the talk. I have one question. You were mentioning a bit about the sandboxes. Can you also speak a little bit to how you set up the proxy part of the Sandcastle?
Yes. So if you go down the Docker route, you essentially set up a network on the Docker container that is only allowed to reach the host via a specific proxy URL where you're sending all the requests through. And then you're running that proxy. I recommend running that proxy in the same, like a sidecar to your main application. So then when you start the Docker container, you can essentially add a session ID or something similar that comes with a proxy call that you can then use to authenticate who ran this request in the sandbox. So you know which user is actually in the sandbox, and then you know what rights that user has. Does it still have any tokens left to run? Is it allowed to use this tool or not? But I'm happy to share the details later.
Good, thank you.
All right, can take a last one down the aisle. Saw this one first, so. Okay, here you go.
Yeah, thanks for the talk. I think you made a great case about the technical security of the solution, and I'm just wondering a bit about the compliance side, especially with cross-national and cross-continental deals. Are there like bigger blockers for you, and what's your approach to solving them?
Okay, so compliance is important for us, and we have all the normal things like SOC 2, ISO 27001, even HIPAA, and we're doing GovRAMP right now. We run in different regions. The sandboxes only lives in those regions, and since everything goes through these proxies, we can actually log everything that's happening at a level that is kind of hard to do otherwise. And those helps a lot when we do penetration testing or getting some kind of certification.
But you do need to adapt locally to where the customer is and what regulatory issues they have.
So it used to be a bigger issue. It used to be that people weren't happy to send things over the country borders or like between Europe and US and Asia. I think the value that a lot of these AI tools bring today outweigh some of the concerns they have, but sometimes they're legally obliged, and then we will spin up a region. For example, in Dubai, no data is allowed to leave Dubai. So then we can only use the models that we can actually run in those regions, which is a subset of all the models that exist. So it's problematic, but it's not as bad as it used to be.
Thanks.